Hey guys, we are going to do chapter 6 now. So we did 1, we did 2, we did 3, we did 4 in class. So I'm not going to give out those answers. 5 we did in class if you're in period 4. And chapter 6, this is our last chapter. So it's basically all the questions we haven't done yet. This one I'm going to skip because I basically had said we'll talk about it. So question number 2, a university has 12,000 female students and 8,000 male students. So that's a total of 20,000 students. 50% of the women use this student gym. So that would be 6,000, right? And 40% of the men use the gym. So if there's 8,000 males, to figure out what goes in this box, 40% of 8. Where's my calculator? I got too many things on here. There it is. $3,200. So it says a simple random sample of 100 students is selected. What is the expected number of students in the sample who use the gym? So it looks like we would expect this proportion, right? 9,200 divided by 23. %. And so that would be of a sample. If this is 46%, that's what percent means. Out of, if you had a sample of 100, how many would you expect? That's 46. Question number 3. A manufacturer battery claims they have a shelf life of 1 year. The manufacturer contends that 99.5% of the batteries will function after sitting without use for 1 year. If the company's claim is true, what is the expected number of batteries in a random sample of 5,000? So we would say we can just multiply the 2, right? So your expected value is equal to n times p. So if we took a random sample of 5,000 and the probability is 0.995, we get 4975. So we're expecting 4975 of those batteries that would function. There's our answer, 4975. All right. Question number 8. It says the paintball range sells paintballs in bulk as well as individual retail sales. Next year, the sales will depend on the market conditions, but the companies believe the following probability describes the wholesale and the retail. Okay, so we want to make sure that this adds up to 1, which it does, and this adds up to 1. What is the expected profit for next year if the profit from each paintball sold is $1 for wholesale and $2 for retail? So I'll just call wholesale X, and my expected would be however many I'm expecting to sell times $1, right? So it looks like I'm expecting to sell somewhere around 100 to 150,000, and that would be dollars. So I'm going to do 50,000 times 0.2 plus 100,000 times 0.3 plus 150,000 times 0.4 plus 200,000 times 0.1. 40% of 150 is 60,000. And then 10%, this would be 20 grand. So you have 60, 70, 80, 90, 100, 110, 120. So you're expecting 120,000 of sales of wholesale and $1 a piece. That would be $120,000. And then on retail, you can sell for $2. So let's calculate that one. Just gonna call that Y. Right, so 10,000 times 0.2 should be 2,000. 20,000 times 0.5, which is 10 grand, and 30,000 times 3%. That'd be 9 grand. All right, so in total, I'm expecting to sell retail 11,000, so 21,000. But I'm going to sell them at $2 a profit. So 21,000 times 2 would be 42,000. So I have 120,000. My mu total would be mu of wholesale plus mu of retail. So 120,000 plus 42,000. And we get our answer C. There it is. Question number 15. It looks like 15 and 16, they give us this breakdown. So it says, every Wednesday, Burgerville has a discount deck day. A customer who comes in with a child may choose to pick 2 cards from a deck. If the 2 cards are the same number, then the child's junior burger is free with a purchase of a mega burger. If the 2 cards are the same suit, okay, so I'm just going to call this event 1. 2 cards, same number. Event 2. If the 2 cards are the same suit, the child's junior burger is half price. The menu price for a junior burger is $2 and the mega burger is $4. Okay, so if we think about this, if event 1 happens, the cost of event 1, the menu price for it is $2. So you get that junior burger free, but you have to buy $4. So you have to spend $4 to get that free burger and the mega burger. The cost of the second event would be you'd get half off the junior burger, so you'd only have to pay $1, so you'd end up paying $5 total for the same food. And if you lose, you have to pay $6, right? If that's what you wanted. So it says, let X represent the amount paid by a customer with a child for a junior burger and a mega burger. And the expected value of X is $5.68. Okay, so we call X either, we haven't figured that out yet, But either you're going to pay $6, $5, or $4. And so you can see how the expected value is somewhere here, right? And a standard deviation of 5.9. So mu x and sigma x. Now let's get to the quick of it. If a customer with a child picks from a deck and purchases both a junior burger and a mega burger every Wednesday for 12 consecutive weeks, what is the total amount the customer would expect to pay for all the burgers? Okay. So we've learned that we can say to ourselves, we would expect the same each time. So we are expecting that $5 and 65 cents. So it would be the mu x times 12 for 12 in a row, right? So $5.65 times 12 times. So 67.80. And that's one of our choices, D is 67.80. Now, maybe you didn't have to kind of think through the whole problem, but let's see, maybe we needed some of that thinking for 16. If a customer with a child picks from the discount deck every Wednesday and buys both a junior burger and a mega burger for 5 consecutive weeks, what is the standard deviation of the total amount paid for all the burgers? All right, so when we think about this a minute ago, if we thought the total for 12 weeks, it was mu x plus mu x, and we just kept adding them up, so it was the same as, and we went 12 of them, and that's why we multiplied, right? Repeated addition is multiplication. Remember, for standard deviation, we would need to find the square root of the sum of the variances in order to have that, right? So this would be the mu total. We'd have to add these up, right? And then again for another day. 5 in a row now, based on this problem. And then we could add variances. We can only add variances. It's so important that we understand we can only add variances, right? And so if we look at this number is the same each time. Okay, so if that number is the same each time, 0.59, then how many of those do I have? I've got 5 of those. So I'm going to do 5 times mu x squared, and that's not going to tell me the standard deviation. That's going to tell me the variance. I'll have to take the square root of that. So this would be the square root of 5 times sigma x squared, which we said was 0.59. All right, so 0.59 squared times the number 5, and then we want to take the square root. 0.59 squared times 5, and then we want to take the square root. So our variance is 1.74, so our standard deviation is 1.319. All right. Double check our answer. That would round to $1.32. Next. Do we still have one more here? It looks like we got 24, 31. Let's keep going. A die is rolled 6 times, and the number of times a 3 is rolled is counted. All right, this procedure of 6 dice rolls is repeated 100 times, and the results are summarized in a frequency distribution. Which of the frequency distributions below is most likely to contain the results from these 100 trials? Okay. So we understand that under normal setting, right, this would be binomial, and the distribution of this procedure of 6 dice rolls. So n is 6, right? And p is 1 out of 6, right? That's the chances of rolling a 3, because there's 6 sides to the dice, and that happens to be one of the sides. So we know x is the number of times that you get a 3. You could get all 6 of them to be a 3, which is relatively rare, right? None of them to be a 3, which we wouldn't expect that. As you can imagine, we can rate our expected value n times p. So 6 times 1 over 6 would be 1. So you're actually expecting to get 1 3. And so again, we would expect for the peak to be at 1. And so I'm just going to go through and kind of highlight this. And we notice that we can already cancel this out. This would be incredibly rare to get do 6 rolls and get 3. So this is definitely out. This one's okay. I don't like how high that one is. I would think that that's too many. And so I actually think A is my best. Because it looks like it kind of makes a peak, which is what I would expect. In 100 rolls, I don't think I would even get 6. And you could actually do this in a calculator. So if we go to go to Google and put in binomial CDF calculator. See if I can, actually, this one would be okay. I maybe would even want a PDF calculator. The number of successes, probability of success is 1/6. Number of trials is 6. And let's see if I hit calculate. Oh, it wants, let's see, I could do a probability distribution of the number of successes must be a number. Let's say your likelihood of getting 1 success. It doesn't like that I didn't make that a fraction. 1 divided by 6 is 0.16 repeating. Oh, that's not what I want. I want back to this internet. 0.166667. All right, let's take that out of there, see if it'll give me that. All right, so if we put number of successes 1, calculate, it gives a binomial probability of 40%, which matches what we had in our question. If I change this to 0 and hit binomial PDF, so I hit calculate again, it says 33%. If I hit 2, it says 20%. So as I go back here, this A is closest to the predictions. Closest to the PDF is the calculations of what frequency I should expect. So I think this one was 20% and this was 30% of some sort. So how do we put this in our calculator? You put binomial PDF and you can put the value that you think that you would have. So you put your N and your P and then your value of X. And so I put each of these values and each of these should give you that output. All right, 25, 26. Here we are, 31. A random variable X has a normal distribution centered at 100. at about 10% of the time, X takes on a value that is less than 80. So 10% of the time, so that's the area under the curve to the left, it takes on a value less than 80. What is the approximate value of the standard deviation? So this is a very interesting problem because it's giving me some pieces that I might have to do this by hand. A z-score is a minus p over s. I can look up in a table A the z-score of 10% to the left. So I think that's probably the quickest way to do this. So table A, AP stats. So I go to my formula sheet here just by kind of Googling it here. Here's my table A. Where's my 10%? So if I look around for this number, it looks like I get 10% at the z-score of negative 1.28. Negative 1.28. So negative 1.28 coincides with this area under the curve of 10%. So your actual value is 80. You'd predict to get the score of 100 because that's the average, and your S. So we can do the Lynch swap, swapping spots of the S and the negative 1.28. And then our numerator is negative 20, and then we can put this in our calculator. So our standard deviation should be 20 divided by 1.28. 20 divided by 1.28. 15,625. 15,625, 15,625. Nice. All right, looking for any other question, chapter 6. That's it. Thanks for joining us, guys.